on Planetterrian Daily, episode S23, coming to you on May 30th, 2026. Here's what's new in science, health, and longevity research. UK data show air pollution directly slows lung growth in children. A large UK analysis tracked lung function in children exposed to varying levels of traffic-related pollutants. Higher exposure to nitrogen dioxide and particulate matter correlated with reduced forced expiratory volume and forced vital capacity. The effect appeared during the growth phase when lung tissue is still developing alveolar structures. Researchers measured annual declines in lung function metrics that persisted after adjusting for socioeconomic factors and smoking exposure in the household. Follow-up work is examining whether reduced exposure later in childhood can partially restore growth trajectories. On a different note, researchers examined the Gulf toadfish and identified symbiotic bacteria in its intestine capable of precipitating calcium carbonate. The process occurs under conditions created by the fish's digestive chemistry and microbial metabolism. Published in PLOS Biology, the work links this activity to broader marine carbon chemistry because the minerals can sink and sequester carbon. Experiments showed the bacteria produced the precipitate even outside the host when supplied with appropriate substrates. The findings suggest fish microbiomes participate in the ocean's inorganic carbon cycle beyond simple digestion. Next measurements will test how widespread this capability is across other marine fish species. The PLOS Biology study on Gulf toadfish gut bacteria shows a direct route by which animal microbiomes can influence ocean carbon chemistry. The bacteria precipitate calcium carbonate inside the fish intestine, creating mineral particles that may sink and remove carbon from surface waters. This adds a biological mechanism to existing models of marine carbon cycling that previously focused mainly on phytoplankton and physical mixing. The work opens questions about how changes in fish populations or their microbiomes could alter rates of this process at scale. What fraction of total oceanic calcium carbonate formation might be attributable to similar fish microbe partnerships? Work published in Science demonstrates that Arabidopsis and other plants actively downregulate immune signaling pathways during some viral challenges. Overactivation of these pathways caused excessive cell death and reduced plant fitness, even when the virus was cleared. The study mapped specific transcription factors that temporarily dampen defense gene expression to preserve tissue integrity. The mechanism involves targeted repression rather than passive failure of detection. This balance resembles the trade-off seen in animal immune systems, where excessive inflammation causes collateral damage. Future experiments will determine whether similar regulatory circuits operate in crop species under field conditions. Most people assume plants either resist infection or succumb to it with little middle ground. In reality, plants constantly adjust immune activity to avoid damaging themselves when a defense would cost more than it protects. Right now, as a virus enters a leaf cell, the plant is measuring the threat level and deciding whether to trigger full-scale production of antimicrobial compounds or to pause that response. One memorable detail is that overactivation of these pathways can kill more plant tissue than the pathogen itself would have destroyed. The next time you see a crop field after a viral outbreak, the surviving plants may have used precisely this kind of temporary immune break, rather than mounting an all-out response. A practical takeaway is to watch for breeding programs that aim to fine-tune these regulatory circuits instead of simply boosting every defense gene at once. A research team is constructing a comprehensive hydrodynamic model that resolves circulation patterns at scales from basin-wide loops to individual particle trajectories. The model incorporates real-time wind, river discharge, and tidal data to predict how water masses and suspended material move. Applications include tracking larval transport for marine biology and forecasting pollutant spread after storms. The effort requires continuous assimilation of new sensor data because small changes in freshwater input alter local eddies within days. Validation against drifter buoys shows improved accuracy over earlier, coarser models. Ongoing work focuses on coupling the physical model with biological modules for nutrient and plankton dynamics. An independent review of Thermo Fisher's antibody product documentation identified numerous duplicated or altered Western blot and microscopy images. The anomalies raise questions about the validation data supplied for reagents used across thousands of laboratories. Antibody cross-reactivity and batch variability have long been known issues in biomedical research. The new findings add evidence that some commercial validation materials may not reliably represent the products researchers receive. No immediate safety implications were reported, but the episode underscores the need for independent verification of reagent performance. Journals and funding agencies are discussing updated requirements for antibody documentation in future publications. Before we go, keep an eye on follow-up measurements testing how widespread calcium carbonate precipitation is across other marine fish species. That's Planetterrian Daily for today. If you enjoyed this, a rating or review on Apple Podcasts or Spotify really helps new listeners find the show. I'm Patrick in Vancouver. Thanks for listening, and I'll see you tomorrow. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.